Hello everyone, welcome to my channel. Today I'm going to talk about GaoKao Math problem. I guess some of you might heard of GaoKao before. The public examination held in China is for the last year high school student in order to get into the university. And it's so-called the most difficult public examination in the world. Is it really the case? Today I'm going to try out. So I'm going to do one of the math problem from year 2023 math science stream paper. Question number 17. Okay, the problem is written in Chinese. I'm going to do some translation for all of you to understand better. Okay, first there is a sequence and the nth term is represented by an. And then the second term, a2, is equals to 1. Next, we have Sn. Sn represent the sum of the first n terms in the sequence. So in other words, Sn is equals to a1 plus a2 plus dot 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 plus an. And lastly, it's given that 2 times Sn is equals to n times an. There are two parts in the problem. First part, we need to find the general formula of an. And then the second part, we need to find Tn, which is the summation of this sequence. Okay, so enough talking, let's do it. Okay, first of all, I will begin with the given equation. So this is nothing but copying the given equation, nothing new here. Next, I'm going to do change of subject to find the expression for Sn. Okay, so it's here. Then next, I'm going to apply another formula. If you see this for the first time, I suggest you to look at this red box. It explains why this formula is true. All right, because if you look at the thing here, after subtraction, the first n minus 1 terms are all cancelled out. So only the last term an remain. So therefore this formula is true. So after that, I'm going to combine the two equations above. Okay, I'm going to replace Sn. Replace it with this expression. So now Sn become this. The next Sn minus 1, I'm going to do similar thing. And the thing I'm going to do is substitute, change all the n, change them to n minus 1. So now we will have the expression for Sn minus 1. So now here, this is the result. Okay, and then next, notice here we have two terms that have an. So I'm going to do change of subject, change an to become the subject of the equation. And then after some simplification, I will get this this line here. Okay, if you look at this line closely, you will find this expression very useful. Why? Because you see that now an, the nth term, is now expressed as something times the previous term, an minus 1. So in other words, we can apply this relationship into the previous term again. Then we will expand this, replace this number with another expression based on the equation here. So to be more specific, look at the steps on the right. I'm going to change n to n minus 1. So all the n will become n minus 1, n minus 1, n minus 1. So next line here, we will have the new expression for an minus 1. So now we can see that an minus 1 is equal to this. So I just change an minus 1 into this. As you can see, just simply copying here. And then next, as you can see, we can repeat this process again and again until we have the index and the last term becomes smaller and smaller until it becomes 2, right? Because we only have the value for up to 2. We don't know the value for a1 yet. All right, so next, you are going to see, okay, this original expression, although it look very long, but indeed we can cancel out. There are lots of term are equals. We can cancel out them. I use highlighter to highlight the parts that are equal. So these two parts are equal, so cancel out. And then indeed all the diagonal parts are the same, so lots of term are cancel out. And at the end, only 3 terms will remain. So which are a minus 1, 3 minus 2, and a2. Okay, so 3 minus 1 is 1, so anything time 1 is itself, so I can ignore it. And then lastly, a2 is given is equals to 1. So at the end, an can be written as n minus 1. So up to here, is it the final answer yet? Think about it carefully. All right, if you think about it carefully, you will notice this thing I wrote here. All the equation above are only valid for n greater than 2. So therefore, there are 2 remaining cases we are not sure yet, which are n equals to 1 and n equals to 2. So next, what I'm going to do next is to check whether this general formula is also true for n equals to 1 and n equals to 2. To do so, I'm going to put n equals 2 into the very beginning equation. So change all the n to 2. All right. And then next, a2 is 1 is given. Nothing special here. And then s2 is equals to a1 plus a2. This is actually from the definition. S2 means the sum of the first 2 terms. Okay, so therefore here, a2 become 1, and then at the end, a1 will be equals to 0. And then next, I'm going to put n equals to 1 into the general formula I found before, and then check whether the 2 numbers here are the same. If they are the same, then we can conclude that the general formula is true for n equals to 1. All right, and then luckily they are the same, so it's true. General formula is true for n equals to 1. And then lastly, just put n equals 2 into the general formula. Okay, and then a2 equals to 1, the same as the given information. So therefore, we conclude that an equals to n minus 1 is really the general formula for all positive integer n. Okay, so that's it for part 1. As you will see, actually part 2 is a bit shorter than part 1. Okay, so let's go to part 2. All right, so part 2 is to simplify this expression here. Okay, the first step is very easy. We are going to use the part 1 result. ak is nothing but k minus 1. So now I can do substitution and then do simplification. So at the end, I will get this expression here. And then here actually is the most difficult part. To be honest, at the beginning, I have no idea what kind of series it is, because although it has k above, It looks like it's a arithmetic series, but it's not indeed because it also has other things at the bottom. And then this thing actually look like the geometric series. So it's neither arithmetic series nor the geometric series. I was very confused at the beginning, so I at the end I do some googling and I search for more insights, and then I find out that there is a Wikipedia page talking about this series, and this series actually called arithmetic geometric series. Okay, if you are interested, you can go to Wikipedia and then search for the article. Uh, in the Wikipedia article, there is a section about the proof of the of this series formula, and then I find that the technique used there is very useful for me to solve this problem. So here I'm going to use that technique. Uh, to be more specific, first I need to write out the series explicitly. So Tn equals to this series here. And then next thing, here I'm going to multiply the whole series with the common ratio of the geometric part. Okay, here as you can see, this expression can be written as the product of the arithmetic part and the geometric part. Okay, so after that, you'll notice one thing very useful. Okay, you notice all the diagonal term. Actually, the number above, the numerator above, the the difference is only 1. So after subtraction, actually all the number in the numerator, uh, except the first and the last term, all the numerator are going to be 1 after the subtraction. And then it gives us a very beautiful expression below. Okay, if we look at this expression below, now it becomes a geometric series plus an extra term at the end. So now I can apply the geometric series formula and then change all the terms here into this expression, then plus the last term. And after a few more simplification, this is the final answer. Okay, so that's all for this problem, part 1 and part 2 done. All right, finally, my reflection time. To be honest, this paper, this problem is very difficult. If I rate the difficulty out of 10, I will actually give 9 out of 10. And what's more crazy is that this is actually not the final answer yet. Not the final problem yet. I think there are 4 or more problems like this in the paper. All right, so therefore, if the student can really finish all the problem in the paper, the student must be very strong in the math foundation, and also they must be doing very very fast because for this exam paper the time is limited. I think it's around 2 hours only. So if the student can finish all the problem in the paper, I think I will be very impressed. All right. So and also one more thing is that actually I learned a new thing about after doing this problem. I learned one more series. Okay, it's called arithmetical geometric series. So overall speaking, this is a very interesting experience, and also at the same time very challenging. Okay, so that's all for my video. Thank you very much for watching. If you have any other more challenging problem, that you want me to do in the future, feel free to comment it. And also, feel free to let me know what do you think about the difficulty of this problem. All right, see you next time. Bye bye.